Hello everyone, and welcome to the second part of this video, which is all about naming compounds. So in part 2, we will talk about molecular compounds and acids. Alright, so if you remember, molecular compounds are different from ionic compounds in such a way that they only contain nonmetals. So for example, if you look at these here, you have nitrogen monoxide, nitrogen dioxide, N2O, H2O, CO2, CBr4. If you analyze these chemical formulas, they don't contain any metals. Okay, and so molecular compounds uh, utilize covalent bonding, which you will learn later on in chapter 9 and chapter 10 that covalent bonding is basically the sharing of electrons, right? Compared to ionic bonding, which is the transfer of electrons from the metals to the nonmetals. All right, so let's look at how we can name these molecular compounds. So in naming molecular compounds, we use prefixes, right? So these prefixes basically indicate how many atoms you have of that specific element within that molecule. Okay, so for example, in the molecular compound NO, you have one nitrogen and one oxygen. In NO2, you have one nitrogen and two oxygens. All right, so these prefixes basically help you identify or uh, help you name the compounds based on the number of atoms of that specific element within that compound. All right, so this is basically the formatting of how you would name these molecular compounds. So first you have a prefix, right, indicating the number of atoms, followed by the name of the first element within that chemical formula. And then for the second element, you would again uh, use a prefix indicating the number of atoms for that specific element, followed by the name of the second element, but this time ending in IDE. Right? So for example, we have NO over here, you have one nitrogen, okay, and one oxygen. So you would name that as nitrogen monoxide. Okay, so if you only have one atom of the first element, you would have to drop the word mono. Okay, so it's already implied that you have one atom of that element in nitrogen monoxide, for example. Same thing with carbon monoxide or carbon dioxide. You omit the prefix mono for the first element. All right, so let's look at some examples here. Again, the example that I gave in the beginning was nitrogen monoxide, right? So you have one nitrogen and one oxygen, and so instead of mononitrogen, you would drop the prefix mono. So it would be nitrogen monooxide, right? It ends in IDE. Or you can just simplify that into nitrogen monoxide. All right, let's look at the second one over here, N2O2. Okay, so this indicates that you have two nitrogen atoms, and two oxygen atoms. So you would use the prefix di, right? So it would be dinitrogen dioxide. So unlike in ionic compounds, you don't have to simplify this into NO. So you can just leave it as N2O2 because this is the molecular formula, right? It indicates the actual number of atoms within that given molecule. All right, so if you'd like to try the rest all by yourself, you can go ahead and pause this video. All right, so the third one here, Ni3, you have a single nitrogen and three atoms of iodine, right? And so you would name this nitrogen triiodide. PCl5, you have one phosphorus and five chlorine atoms. So that would be phosphorus pentachloride. P4S10, you have 4 phosphorus, which would be tetra, and 10 sulfur atoms, so that would be deca. So naming this would be tetraphosphorus decasulfide. CCl4, that would be carbon tetrachloride. And then we have carbon monoxide, carbon dioxide, and xenon difluoride. So it looks like that's pretty much it for naming molecular compounds. You may be given the name of the compound itself, the name of the molecular compound, and then you would have to come up with the chemical formula, right? So for example, if you were given tetra phosphorus decasulfide, then you know that there are 4 phosphorus atoms followed by 10 sulfur atoms. All right, now let's take a look at how to name acids. So acids are basically an example of molecular compounds which release hydrogen ions when dissolved in water. So for example, if you have hydrochloric acid, which is HCl, if you dissolve that in water, it would dissociate into hydrogen ions and chloride ions. But these compounds, these acids, are molecular compounds, not ionic compounds. The reason why is because the bonding is different within these molecules. It's covalent bonding. All right, so acids are capable of dissolving most metals, like for example zinc, iron, magnesium, sodium, so on and so forth, but they're not strong enough to dissolve gold, silver, or platinum. And a lot of these acids have sour taste. They have pH less than 7, and so they turn litmus paper red. And here are some examples of different types of acids. You have ascorbic acid, which is also known as vitamin C. There's hydrochloric acid, hydrofluoric acid, and even bromic acid. So bromic acid is a type of acid that contains polyatomic ions, right? Ions that contain multiple different atoms or elements. All right, so as I mentioned earlier, hydrochloric acid, HCl, when you dissolve that in water, it forms ions such as hydrogen ion, which is a cation, and a chloride ion. Acids start with hydrogen in their chemical formula, right? So HCl is one perfect example. You have H2SO4, which is sulfuric acid. You have HNO3, which is nitric acid. There are 2 different types of acids. The first one is a binary acid, which means it's an acid that contains only 2 elements, and one of those elements is a hydrogen. And the other element would be one of those halogens. Oxyacids, on the other hand, are acids that contain oxygen. And these are your polyatomic anions, like the chlorates, nitrates, sulfates, so on and so forth. All right, so again, binary acids contain 2 elements. Oxyacids contain multiple different elements. So let's focus on the easy one here and learn about how to name binary acids. All right, so here are some examples of these different acids. So you have HF, HCl, HBr, HI. So as you notice, they only contain 2 different elements, and one of those elements is a hydrogen and the other your halogens. For oxyacids, you have those polyatomic ions that are interacting with a hydrogen or bonded with a hydrogen element. So you have HNO3, HClO3, HBrO4, and so on and so forth. Okay, so how do we name binary acids? Right, so the first one here is HF. Um, and whenever we name binary acids, it always starts with the prefix hydro. Okay, so in this case, we have hydro and then fluoric acid. All right, so the second element here is a halogen. Right, so instead of calling it fluorine, you would change the suffix ine into ic, right? So it would be hydrofluoric followed by the word acid. So the first one here is hydrofluoric acid. The next one is HCl. So you would name that hydrochloric acid, right? So here's the formatting of how you would name a binary acid. Again, it always starts with the word or the prefix hydro, followed by the name of the nonmetal, but ending in IC. All right, again, the second one here is hydrochloric acid. The third one is hydrobromic acid. And the last one is hydroiodic acid. For the second type of acid, it's a little bit more challenging, right? So you have HNO3, HBrO3, all the way down to H2SO4. So how would we name these acids? So whenever you're naming an oxyacid, right? So you can tell that it is an oxyacid because it contains oxygens. It contains polyatomic ion, right? The polyatomic ion here in HNO3 is the nitrate ion, okay? And so if the polyatomic ion ends in ATE, such as nitrate, all you have to do is replace the ATE with the suffix IC, okay? So it would be nitric acid. All right, so again, here's the formatting. So you would use the base name of the polyatomic ion. If it ends in ATE, such as the nitrate ion, you just replace it with IC followed by the word acid. Okay, so let's try the rest here. Again, you can pause the video if you'd like to try it by yourself. The first one is HBrO3. So analyze the chemical formula and you can see that HBrO3 contains the polyatomic ion bromate, right? So this is the bromate ion, BrO3. So you can see that it ends in ATE. So all you have to do is replace ATE with the suffix IC. So this would be bromic acid. The third one here is the polyatomic ion iodate ion, IO3 with a negative charge. And so the acid is called iodic acid. Okay, the third one here is the chlorate ion, ClO3 with a negative charge. And the acid is chloric acid. Okay, so for the last two here, it's a little bit special. Okay, so we have PO4 as the polyatomic ion, right? PO4 with a negative 3 charge, PO4 3 minus, and this is the phosphate ion, right? Phosphate. It still ends in ATE, but you wouldn't call this phosphic acid. Instead, this is actually phosphoric acid. Okay, same thing with H2SO4, right? So SO4 with a negative 2 charge is the sulfate ion, but you wouldn't call it sulfic acid. Instead, it's sulfuric acid. All right, so what about the other oxyanions, right? The other polyatomic ions that end in ITE or polyatomic ions that start with the prefix per or hypo, right? How do we name these polyatomic ions? So let's go with polyatomic ions that end in ITE. If you have these oxyacids, you would replace the suffix ITE with OUS, followed by the word acid. All right, so let's take a look at some examples here. So notice that the first one is HNO2, right? If you had NO3 ion, that would be called nitrate ion. But if you subtract one less oxygen from the nitrate ion, you would have the nitrite ion, right? So here we have a nitrite ion. And so all you have to do is, whenever you're naming this acid, you would replace ITE with OUS, followed by the word acid. So in this case, it would be nitrous acid. Okay, if you'd like to try the rest here, you can pause the video. All right, so for the second one, we have HBrO2, which is the bromide ion. BrO2 is the bromide ion. And so to name the acid, it would be bromous acid. Okay. The third one is the iodide ion, IO2 with a negative charge. And so the acid HiO2 is called iodous acid. Okay. And the fourth one here is the chlorite ion. So the acid would be chlorous acid. All right, again, for the H3PO3 and H2SO3 is a little bit different, but you would name it similar to how you did it for phosphoric acid and sulfuric acid in the previous slide. So H3PO3, you have PO3, which is the phosphite ion. And in H2SO3, you have the SO3 ion, which is the sulfite ion. And so in the phosphite ion, instead of naming it phosphorus ion or acid, it would be phosphorus acid, just like how it was for the phosphoric acid. All right, again, H3PO3 is the phosphorus acid. And the second one here is, or the second to the last, or the last one here is the sulfurous acid. All right, what about for these two examples here at the bottom? We have H3PO2, which is again one less oxygen from PO3, and HClO4, which is one extra oxygen from ClO3, the chlorate ion. All right, so let's look at H3PO2. So PO2 is the hypophosphite ion, hypophosphite. All right, and so naming this acid would be hypophosphorus acid. All right, and the last one here, HClO4. Again, ClO4 with a negative charge is the perchlorate ion. All right, so it starts with the prefix per and ends in the suffix ate. So if it's ate, the acid name would be, you would replace ate with IC. So it would be perchloric acid. All right, let's look at some examples here. Let's say you were given the acid's name, and then you would have to come up with the chemical formula. How would you approach this type of problem? So let's take a look. So the first one is nitric acid. Again, you can see that the chemical name ends in IC, right? Nitric acid. So this tells you that the ion must end in ATE, right? The polyatomic ion ends in ATE. And so this would be based off of the ion nitrate. All right, so the nitrate ion is NO3 with a negative charge. And so if you were to react this with a hydrogen ion, H+, and you perform the crisscross method, you get HNO3. So that would be the chemical formula of nitric acid. And you can do the same thing for chloric acid, right? So again, it ends in IC, so that must mean that what we have here is the chlorate ion. Okay, so that's the polyatomic ion, chlorate. So the chlorate ion has the formula ClO3 minus. Again, you react that with a hydrogen ion and you will get HClO3. Bromic acid, the same way. So you have BrO3 with a -1 charge, and you react that with a hydrogen ion and you get HBrO3, the chemical formula of bromic acid. All right, so the last one here is hydrofluoric acid. So when you look at the name, it starts with the prefix hydro. So every time you see the word or the prefix hydro, you know that it's going to be a binary acid containing only two elements. And one of those elements is going to be a hydrogen, and the second element is going to be a halogen. Okay, so in this case, fluoric, that must mean that it comes from the element fluorine, right? So you have a hydrogen followed by fluorine. Okay, so it's HF. All right, let's look at a few more examples here. Again, you can pause the video and see if you can solve these examples. All right, so the first one is perbromic acid. Again, it ends in IC and it starts with the prefix per. So that means you have one extra oxygen from the bromate ion, right? So it's a perbromate ion, which means you have a BrO4 minus, and it starts with a hydrogen. So you use the crisscross method here, and you get HBrO4 as the chemical formula for perbromic acid. What about for nitrous acid? So you notice that it ends in OUS, so that must mean that the polyatomic ion has the suffix ITE. Right, so it must be the nitrite ion. So the nitrite ion is NO2 with a -1 charge. So when you cross that with the hydrogen, you have HNO2. Okay. Third one is sulfuric acid. So this ends in IC, and this is a polyatomic ion sulfate. Okay. So you have a sulfate ion, which is SO4 with a -2 charge. If you cross that with a hydrogen ion, it would be H2SO4. Hypobromous acid. So it starts with the prefix hypo. Okay, so that must mean that you only have one oxygen in the bromate ion. So it would be hypobromite ion. And a hypobromite ion has the formula BrO with a negative charge. So when you cross that with the hydrogen, it would be HBrO for the acid, hypobromous acid. All right, for sulfurous acid, again, it ends in OUS. So that must mean that the polyatomic ion has the suffix ITE. So here we have the sulfite ion, which is SO3 with a -2 charge. Cross it with the hydrogen, you get H2SO3 for sulfurous acid. All right, so this next acid here is read periodic acid, not periodic acid. All right, so you have an iodate ion. I should say periodate ion because it starts with the prefix per. And periodate is IO4 with a -1 charge. So cross that with a hydrogen and you have HiO4. Carbonic acid has the carbonate ion, which is CO3 with a -2 charge. And react that with the hydrogen ion, you have H2CO3. And the last one here is hypochlorous acid. Right? Again, it's ends in OUS, so that must mean that the polyatomic ion has a suffix ITE and a prefix hypo. So that would be hypochlorite ion. Cross that with a hydrogen. So here you have a ClO with a -1 charge. And that would be HClO as the chemical formula of hypochlorous acid. All right, so that basically ends naming compounds. Hope to see you guys next time.